Okay. Hello, my name is Marius Petria, and together with my colleague Quentin Vecchio, we will be presenting the new configuration capabilities for the out-of-the-box CDN that comes with AEM Cloud Service. So, first of all, let me tell you a little bit about ourselves. So we are Adobe engineers in the AEM Cloud Service Foundation team, more specifically working with content delivery. So essentially with the infrastructure layers of CDN and dispatcher. And the topics that we are dealing with in these layers are caching most of all, and then routing, but also request transformations and response transformations, and yeah, also authentication we are considering. So all these kind of topics that can be done on the request flow. Yeah, the agenda for today is I will do a general introduction in the new CDN configuration capabilities, and Quentin will do a deep dive using some of these for traffic protection and WAF. Let's first recap a little bit where the CDN sits in AEM Cloud Service. First of all, the CDN was a new addition for cloud service. I mean, for the out-of-the-box product. It is always provisioned for an environment. All requests, incoming requests, go through the CDN. And you cannot bypass it. You can put eventually another CDN in front, but you cannot bypass it on the request flow. And then typically we have for AEM Cloud Services, we have the dispatcher and AEM. This is the published view, but the author doesn't have a dispatcher, and I realized today, after hearing all these talks about edge delivery, we don't have this covered here in this diagram, but edge delivery comes also with a CDN. It might be a bit confusing. The CDN used for edge delivery, as it is, it's mostly to configure, to expose an origin. Edge delivery is an origin that you typically configure for your own CDN. But we are also supporting an Adobe Managed CDN. It has been recently launched in Cloud Manager, an Adobe Managed CDN that you can configure in front of your edge delivery services. Now, the CDN since the AEM Cloud Service launched was not really configurable. There were only a few aspects that you could configure: the custom domains and the IP allow lists, but there are a lot more things that can be configured in the CDN, like manipulating headers, rewriting the paths, writing WAF rules, blocking traffic. You can also do client redirects or proxy to other to different origins than AEM. Of course, you could do most of this, if not all, in AEM itself, doing proxies and so on, but also in Apache, that was also a typical place. You could set headers on the response, do proxies with mod proxy. But there are obvious advantages of doing this at the CDN. So typically doing things at the outermost piece of infrastructure is better. For security, you should always try to stop the attacks at the edge so that they don't get into the inner layers of the infrastructure. But also if you are doing request transformations or you remove headers, you change the paths, it's better to do it as soon as the request comes in so that your application sees the same request in the whole stack. But also, there are, as you saw, Adobe is moving and AEM is moving to more serverless architecture where there is no dispatcher, there is no AEM. So if you want to do this header manipulation or path manipulation, you simply don't have those classical places anymore. So that's why we worked at introducing a direct way of configuring the CDN, and that's done now through a pipeline that is deployed through Cloud Manager. There is a new type of pipeline, a configuration pipeline, that takes a file, a YAML file that has some sections for these things that can be configured. We have an example here, and deploys it. The deployment is rather quick. It's minutes, and you can configure all these things. I will show here a diagram to show the request flow essentially in the CDN. So the browser makes a request. The first things that are executed are the request transformations, so you can remove headers, rewrite the path, and so on. Then you decide, is the traffic okay? Should it be allowed? For that, you have the traffic filters. And then authentication looks at the credentials of the request. Is this a path that needs authentication? If yes, is authentication, are the credentials okay? And then you can also do client redirects, and in the end, in this request flow, you select an origin, either let it pass to the AEM origin or send it somewhere else. The response can come from the cache or from the actual origin, and then you have the last chance of interacting with the request response flow by changing something in the response. So, as I said, the configuration is a YAML file. It looks something like this. So this is a simplified view. You can define rules. The rules have a condition, a when condition, and an action. The conditions can be quite powerful. So you can write conditions on whatever is in the HTTP request. So on the path, query string, the method, the URL. So, but also on you can write conditions on client IP. So the IP of the connecting client, and also we have some geolocation properties, client country, client region. So these are useful, especially for WAF use cases, and Quentin will talk more about this. But also concepts for AEM, for the AEM environment, like tier, which is author, publish, preview, or the domain of the actual request. You should always try to guard your rules with one of these so that the rules don't apply to the entire environment. So if you block a path, you don't block it also on author, you just block it on publish. You also have access to all request and response headers, cookies, post parameters, and also there is a concept of variables that allows you to pass information from one stage to another. So you can set it in a request transformation and read it later, but this is a more advanced use cases. I will go through each of these now and explain you or give examples of the typical use cases. So the request transformations are as I said, the first ones that are running, and it is the chance to normalize the URL and sanitize the request header. So I would emphasize the URL normalization because it allows you also to maximize the cache ratio. So if you have an extension-less site, you can strip the HTML with the .html with a request transformation, so that your page with .html and the one without an extension hit the same cache key. So the cache key is evaluated after the request transformations are evaluated, and the cache key typically contains the domain and the URL. So you can minimize the space of the cache keys by just rewriting everything to their canonical form. Also, you can sanitize the request headers. So I would recommend remove, for example, the authorization header or authorization cookies if you don't use authorization on your site. Again, this has an effect on the dispatcher, actually, because dispatcher doesn't cache things with that have authorization header. So by sanitizing these request headers, you avoid requests that can avoid the cache, so cache busting techniques. Okay, so here is a full example of how these rules will look like. As I said, you have a condition, a when condition typically, and an action, and then you can target, the first condition is doing, it's applying for a specific domain, www.example.com, and the path search, and it removes every query parameter that does not match search ID. So essentially, it allows only the search ID query parameter. Now, I would say that in general, you should try to start removing all query parameters. So if you don't have the need for query parameters, just remove all of them. Edge delivery services don't support query parameters. It's a very effective way of maximizing cache hits. The second one is unsetting a header. So, and we have also a property there, which is besides rules, we also introduced out-of-the-box property with special meaning, like remove marketing parameters. So this is if you don't remove all of your parameters, at least set this to true, so that all the marketing parameters from social media or things like that do not bypass the cache. Next, in the request flow, as I showed, are the traffic filters, but I will not insist on this. These are for, because Quentin will talk about this, these are for blocking and allowing traffic. We also have an authentication section, but we only implemented some specific use case for now. So we allow setting up authentication by requiring a specific secret in a header, and this is used for integrating your own CDN in front of Adobe Managed CDN, and also allow setting up keys for purging, and also to declare username passwords for basic authentication. This is not a full-fledged, basic authentication is not a full-fledged authentication mechanism. It is typically used only for lower environments or pre-live environments, but we got this request often, so, and is limited, for that reason, is limited to 10 users, so you can only define a small number of users. After you pass through the request transformations, the traffic filters, authentication, and so on, everything you are confident on your traffic, you can start do things like redirects. The redirects are more for systemic redirects, like you redirects from Apex to www or strip HTML and redirect to the canonical form. Or you can do country-specific redirects. You detect country client is from Germany, you redirect to the German homepage. You can use regexes and capture groups in these redirects. But what is to have in mind here is that the entire CDN configuration is limited to 100 kilobytes. There are technical reasons for that. And you cannot do huge maps of redirects in these 100 kilobytes. So we have customers that have hundreds of thousands of redirects, and those should sit either in AEM or dispatcher still. So after all this, it's time to basically send the request to the origin, and this was again a very requested feature to integrate external origins. Mainly, I mean, it allows you to be fast. If you integrate origins on the same domain that you are serving the content, you don't need another TLS handshake. And you can do mostly all the things that you need to do. You can rewrite the path so that you match the target URL structure, and inject secrets, and caching is also respected. And I have here an example how to route parts of your site of your cloud service site to EDS. So you will do this with origin selector. And I will rush a little bit through my last slide. So the last thing is, after the response comes from the origin or from the cache, you can modify the headers or the status of the response. You cannot modify the body. For this, you would need some more advanced infrastructure like compute. We are lambdas or things like that, workers. We don't yet offer this possibility. We are exploring it, but for now, you can only modify headers and status. That's my presentation for the typical customizations that you can do. And next, I will let Quentin talk about traffic protection.
Thank you, Marius. So for the rest of the presentations, we will be talking more about the security aspect introduced by the new CDN capabilities. And we will be focusing on one specific kind of CDN rules called traffic filter rules. So with this kind of rules, you can now block, log, and allow traffic directly from the CDN and based on request patterns. So as you can see, traffic filter rules respect exactly the same syntax as other rules that Marius just presented. And here we have a couple examples how you could, for instance, block IPs, block countries based on IP geolocation, or how you could even log any attempt of logging on your website. Of course, with traffic filter rules, you can also try to block more advanced patterns. I will even say you could even try to develop your own simple WAF that you will deploy at the CDN. So here a few examples how you could look for SQL injections by looking to the most common SQL keywords in the query string. How you could block path traversal attack on your website, or even how you could block PHP extensions, as AEM is not doing anything with PHP, and PHP is one of the main target of vulnerability scanners. It just makes sense to block it. While it's pretty cool, it has some inconvenience, I would say. First of all, because it's still regex approach, so it means you will need to be careful during crafting your regex. You will have to monitor really closely your CDN traffic to be sure that no attacker managed to bypass your rules. And it also has some limitations, technical limitations, not coming from the CDN rules directly, but from the underlying language your rules will get compiled to, which is VCL. For instance, VCL doesn't provide you a way to iterate through request header. So if you would want to look for an XML exploit in request headers, you will have to explicitly mention every request header you want to inspect. A second limitation is around the body of the request. So here as well, VCL doesn't let you inspect the entire body. So it means if the exploit is coming from the request body, it will bypass your rules. But of course, if customers need more advanced protection, Adobe actually released an AEM WAF at the beginning of this year, and this AEM WAF that will run at the CDN will offer you better protection against OWASP top 10, so SQL injection, XSS, etc., as well as protection against anomalies. It will be able to detect requests coming from scanners, requests trying to access non-private files such as environment configuration file, etc. And it will also be able to identify known bad actors, so malicious IPs, malicious bots, etc. So while the traffic filter rules are completely free, the AEM WAF comes as a self-serve product with its own SKU. It has its own license, so you will need to license it in order to be able to use it. But it comes with a pre-configured set of rules that you can just enable and disable directly from the traffic filter rules. So here we have an example how you could simply block any OWASP top 10 traffic on your website by writing traffic filter rules in blocking mode and just enabling the following WAF flags. So as you can see here, there is no notion of regexes anymore. You will rely on the AEM WAF, and so it means it will be more robust because it will be able to analyze the overall content of the request. And it will also save you a lot of time because you will not have to monitor as closely your traffic as before. So now that you know about the tools, how to protect your website, you might wonder, how do I know that I'm getting attacked? And for that, Adobe provides also some tools and dashboard for you to analyze your CDN traffic. They come in two variants. The first one is a Elasticsearch Kibana stack that you can install locally on your laptop. You will download your CDN logs from Cloud Manager, ingest them, and then you will have access to this kind of dashboard. The second variant is for customers that can forward their logs to their own Splunk instance. We also provide a Splunk dashboard that you can install in your own instance, and you will have access to similar dashboard. So I was not planning to dive into those dashboards, but because there are like a lot of information here, but you will find the most common metrics, top IPs, top URLs, top user agent, traffic over time, etc. If you are WAF customers, you will also see WAF data over there. So you will be able to tell what kind of vulnerability attackers are trying to exploit on your website. And we have plenty of tutorials that cover how to use the dashboard and how to use the data, use the knowledge to come up with appropriate rules. Just a parenthesis, we also have dashboard for cache hit ratio, cache coverage that I also recommend you to look into if you want to improve those metrics on your website. So now for the rest of the session, let's focus on one specific kind of attacks called DDoS attacks. So in today's world, any website can be the target of a DDoS attack. And so that's why Adobe actually does provide out-of-the-box protection. They come directly from the CDN or CDN provider that will protect you against a TCP/IP level attack. And on top of that, Adobe provides HTTP protections, HTTP level protections that mainly leverage a rate limiter. So every AEM as a cloud service environment is equipped with a rate limiter that will protect him from a very volumetric attack. In the unfortunate event your website will be attacked and the DDoS protections would kick in, we will start blocking traffic, of course, but we will also notify you via Action Center and via email that your environment is getting attacked, and we are mitigating it by blocking traffic. And if that ever happened to you, we also recommend you to download your logs, use the dashboard I just showed you, in order to better understand the traffic and the attack, and to be able to come up with your own protection and better mitigate future attacks. And how can you protect yourself from DDoS protection? Well, by leveraging the rate limiter in the traffic filter rules, and it's super easy to use. So here we have an example how you would limit the number of requests per IP. So as you can see, we define a traffic filter rules in blocking mode, and we define a rate limit property that is defined by a limit and a window. So it's basically the average number of requests at which point the rate limiter will kick in. The penalty is simply the number of seconds the IP will get blocked. We have a group by property. So here it's set to client IP, but you can actually rate limit whatever you want, user agent, path, etc. And then we propose 3 variants of rate limiter through the count property. So the count all, we will simply count all requests that goes to the CDN. The count fetches is to count only requests that goes to origins. And the final one is a count errors to count only both client and server-side errors. So obviously we recommend to use the 3 variants, so to have a high limit to count all requests, to have a lower limit to only count fetches, and to have if you want also a limit for errors. And every variant will basically protect different things. The count all will more like protect you content request budget. The count fetches will basically protect your origin and mitigate any outage, and count errors will block, I don't know, vulnerability scanner, for instance, that are trying to access a known URL, or even block IP that are making too many requests, and that trigger some server-side errors. So it could be an indication of a pre-outage, so it will make sense to block them. And in the action, we also have an alert property that, when set to true, will actually alert you via Action Center and via email when the traffic filter rules will get triggered. So a question we also often get is what should be the limit? And to be honest, we don't really know, because it depends so much on your website and on your expectation. But what we recommend is to use a dashboard where we expose actually the number of requests per IP, the maximum number of requests per IP at the origin, at the CDN, and for errors. And so a recommended thing is to look for the accurate value, basically based on your own data. So here, for instance, we see the maximum number of requests at the origins is less than 20. So okay, maybe 60 looks like a good limit. So yeah. So before we end the presentation, we actually had a few tips to share with you to ensure like a good protection against malicious traffic as well as DDoS. So the first thing, please try to ensure fast response from origin. So it means don't take 1 minute to generate a response, because first of all, it's not really good for user as a user experience, but it could also be seen as a vulnerability actually. An attacker would try to leverage that by sending far less requests, and it will likely lead to an outage. The second tip that goes kind of hand-to-hand with the first one is to try to leverage good caching. So the reason is CDN can simply scale much better than your origin will ever do. So if you can serve most of the traffic from the CDN cache, it means during a DDoS attack, the CDN will be able to absorb most of the attack. And one good thing here is to, as Marius already mentioned, try to remove unknown query parameters, so it will protect you from a cache busting attack. Third, use the dashboard, especially to set your own rate limiter, because it will show you the most important data, and you will be able to get an understanding of what you need to block, etc. Try to also leverage different strategies. So here what I mean is, for example, if you are only doing local business, so you only serve, I don't know, German customers, then it makes sense to have one rate limiter for a user based in Germany, and the second one that is far more restrictive for users that are based outside of Germany. Next, don't forget to set up alerting, because it's the only way you will be able to tell your environment is under attack. You won't sit in front of your laptop the whole day looking at CDN logs. And finally, try to always start with action log before you move to block, because if you deploy a broken rule to your production environment, it can have like some really bad effect, and you might block every customer's add-on. So be careful with that. And so with that, thanks a lot, and we are looking forward for what you will manage to achieve with the new CDN capabilities. Thank you.
So last and final question round for today. Like, first of all, it's about bypassing the CDN to execute tests against the dispatchers. Like, especially like the CI/CD solution wants to do this dispatcher tests. How is that possible?
You cannot bypass it at infrastructure layer. Mm-hmm. So, because of various reasons, but essentially security protection. And but what we've recommended to customers until now is to bypass it with a query parameter, exactly what we said here. You should deny, but for this kind of test scenarios, so you can add a random query parameter, bypass the CDN cache, and then if you want your dispatcher not to be bypassed as well, you can put that one into that specific query parameters into the ignore URL parameters of the dispatcher, so that the dispatcher removes it. So there are ways, but you cannot bypass at the infrastructure layer.
Okay, understood. Is there a way to test and develop the CDN features somewhere, like locally or some other place? Because testing it on the cloud environment doesn't seem like a good idea.
I mean, you can leverage RD, so you would still test against the CDN, but deployment is really, really fast. Like, I don't know, 30 seconds maybe.
So the rules are compiled into VCL, and you cannot test them locally. No. So you have the best option will be RD. So you have to.
Okay.
This is a native cloud infrastructure. So we are dealing with the CDN. We cannot have a CDN locally.
RDs. So. When blocking traffic, can you set a custom response HTML, or will it give a technical unbranded standard page?
Yeah, that's a good question. So in traffic filter rules, you can set, first of all, a custom status. And another feature we didn't demo today, for sake of time, is error pages. So you can also now implement your own custom error page, and therefore, on the request will get blocked, we will actually serve your own custom error page.
All right. Last question for the day. Is there a static analysis tool to check configurations before submitting it to the repository?
Not today. So we are maybe thinking of exposing this. We have a JSON schema for the validation. For the configuration, but we are not exposing it today. So.
All right. Something for next adaptTo, maybe.
Yeah, exactly.
Great. Thank you, Marius and Quentin.
Thank you.
Thank you.